Hello there, and welcome. I'm really glad you found your way here. Maybe it's the end of a long day and you're ready to let your mind drift. Or maybe you're the kind of person who likes to fall asleep with a little mystery beside you. Either way, you're in the right place. There's nothing you need to figure out right now. Just breathe. Let your thoughts grow quiet. Let your body grow soft and still. Tonight, we're going somewhere distant, not just in space, but in feeling. Past the comfort of warm stars and into the quiet, cold beyond. We're traveling to Pluto, the most famous misfit in the solar system. Not quite a planet, not quite forgotten, a world of frozen landscapes, hidden oceans, and puzzles that stretch deeper than we ever imagined. This is not a science lesson. This is a soft descent into wonder. 100 truths about a world on the edge, told slowly, patiently, one fact at a time. Not to explain it all, but to marvel at what we know and at everything we still don't. Now take a deep breath, let your day drift away, and let's travel together into the quiet corners of the universe. In the long, restless dark beyond Neptune, there was once a suspicion, a tiny tug, a wobble in the orbits of the outer planets that hinted at something else, something unseen. Astronomers in the early 20th century believed there must be a ninth planet, a hidden wanderer exerting its silent pull from the fringes. They called it Planet X, not because they knew what it was, but because they didn't. It was a placeholder for a mystery, a symbol of something that felt just out of reach. At the Lowell Observatory in Arizona, a young assistant named Clyde Tombaugh took up the search. He was meticulous, patient, and only 24 years old. Night after night, he compared photographic plates, glass images of the same section of sky taken days apart, searching for something that moved against the backdrop of still stars. The work was delicate, mind-numbing, and demanding. But in late February of 1930, he saw it. A faint smudge of light had shifted. It wasn't a star. It wasn't an artifact. It was something real. It was moving, and it was new. News of the discovery spread quickly. A new planet had been found. The solar system, already grand and complex, had grown again. Headlines around the world declared it the ninth planet, a triumph of prediction and perseverance. Astronomers celebrated, the public marveled, and Clyde, quiet, humble Clyde, had changed the map of the sky. The new world needed a name. Suggestions flooded in from every direction. Atlas, Minerva, Zeus, each one reaching for myth and meaning. But the name that stuck came from far away, across the Atlantic, from an one-year-old girl named Venetia Burney in Oxford, England. She loved mythology and followed astronomy with quiet fascination. When she heard about the discovery at breakfast, she suggested Pluto, the Roman god of the underworld, ruler of the cold and distant. It was perfect, remote, mysterious, and in keeping with the other planetary names drawn from ancient gods. Her grandfather passed the idea to a friend at the Royal Astronomical Society, and soon the name was on a telegram bound for Arizona. The astronomers at Lowell liked the sound of it. Pluto, a name that evoked shadows and silence, but also power. They approved it quickly. Officially, the ninth planet had a name, one chosen by a child who saw something poetic in the dark. As a coincidence, the first two letters, P and L, also honored Percival Lowell, the founder of the observatory and the man who had started the hunt for Planet X years before. But what had they really found? At first, there wasn't much to go on, just a blurry dot on a photographic plate. It looked like a planet. It moved like one. It seemed to belong. But Pluto was small and faint and impossibly far away. For decades, that was all we really had. A distant point of light, orbiting in silence. Still, the world fell in love with it. Pluto appeared in textbooks, in planetmobiles, in children's stories and classroom models. It was remote but included, a quiet underdog at the edge of the family. In a solar system full of giants, it was the strange little sibling, and that only made people love it more. Its orbit was odd, highly elliptical, tilted far off the plane of the other planets. Sometimes, it even drifted closer to the Sun than Neptune. Its size was modest, smaller than Earth's moon, and its brightness didn't suggest anything majestic. But none of that mattered. It had a name, it had a place, and for most of the 20th century, Pluto was simply our ninth planet. Astronomers struggled to see it clearly. Early telescopes revealed little more than a dot. Even with the most powerful ground-based optics, Pluto remained stubbornly obscure. Its surface, its color, its character, all of it was hidden by distance and light years of quiet. But despite the lack of detail, curiosity deepened. What kind of world lay that far from the Sun? Was it cold rock, frozen gas? Did it have moons, atmosphere, oceans? Each new photograph brought more questions. The Hubble Space Telescope offered better views, pixelated and rough, but enough to spot hints of surface variation. Light curves suggested a rotation. Shadowed patches hinted at possible ice. In 1978, astronomers discovered Charon, Pluto's largest moon, orbiting so close and in such proportion that the two were more like a binary pair than a planet and its satellite. Suddenly, Pluto wasn't alone. It had a companion, a dance partner in the dark. Still, real details remained elusive, and maybe that was part of the appeal. Pluto was the solar system's blank page, a place where imagination could drift. For generations, it was the mystery world, the placeholder at the edge, the place you could dream into. In classrooms and science fairs, children pointed to it. A cold planet, a small planet, a distant world. It didn't matter that we knew so little. The very act of not knowing made it magnetic. Pluto became a symbol of what was still out there. Proof that the solar system was unfinished, still being explored, still revealing. Its discovery was a reminder that even in a sky charted for centuries, something new could still be found. And perhaps that's what made it so powerful. Pluto wasn't discovered with a massive telescope or a grand expedition. It was found by a farm boy from Kansas, hunched over stacks of glass, chasing a theory older than he was, and named by a girl, half a world away, who understood something deep and silent in the name of a god. It was a planet born from quiet dedication and youthful wonder, and for the better part of a century, it kept that energy. Not a world of facts and clarity, but of mystery, myth, and longing. Pluto was never just a planet. It was always something more. A question asked by a sky full of stars, and answered, softly, by two children who had never met. In August of 2006, a quiet decision made in a warm conference room in Prague reshaped the way we look at the solar system. Astronomers from around the world had gathered for the 26th General Assembly of the International Astronomical Union, and on their agenda was a question that had hovered, unresolved, for decades. What exactly is a planet? For most people, the answer seemed simple. Planets were the 9 familiar names, Mercury through Pluto, etched into memory from textbooks, model kits, and schoolroom posters. But science is rarely satisfied with simplicity for long, especially when new discoveries begin to stretch old definitions. In the years leading up to the meeting, powerful telescopes had uncovered other small icy bodies orbiting far beyond Neptune, some nearly the same size as Pluto. One of them, Eris, discovered in 2005, was thought to be even larger. It forced a dilemma. If Pluto was a planet, should Eris be one too? And if so, what about the dozens of other icy worlds scattered through the Kuiper belt? Could the solar system soon have dozens, even hundreds of planets? The IAU decided it was time to draw a line. They proposed a formal definition. To be considered a planet, a celestial body must orbit the Sun, be massive enough for its gravity to shape it into a nearly round form, and, most crucially, it must have cleared its orbital neighborhood of other debris. Pluto met the first two criteria easily. It orbits the Sun, and its gravity gives it a round shape. But the third? That was where it faltered. Pluto shares its orbit with many other icy bodies. It doesn't dominate its region of space the way Earth or Jupiter does. It hadn't cleared the neighborhood, and with that, the line was drawn just wide enough for 8, and Pluto was left on the outside. The vote happened on August 24. A room of just a few hundred astronomers, out of the thousands who had attended the conference, raised their hands. And just like that, Pluto was no longer a planet. It was reclassified as a new category, a dwarf planet. The term was meant to clarify, to organize, but instead, it sparked one of the most emotional reactions the scientific world had seen in decades. To the scientific community, it was an attempt at precision, but to the public, it felt like a betrayal. People reacted not with apathy, but with grief. Children who had memorized the 9 planets felt like they'd lost a friend. Teachers scrambled to rewrite lessons. Cartoonists, columnists, and comedians weighed in. News anchors discussed it like a celebrity scandal. Pluto, cold, small, and distant, had been demoted, and people weren't happy. Why did we care so much? Maybe it was because Pluto always felt a little like us. Small in a solar system of giants. Strange, tilted, different. It had never quite fit in with the others, and yet it had always been there, circling quietly for 76 years in our charts and imaginations. Its size didn't diminish its presence. If anything, it made it more endearing. Pluto was the underdog planet, the quiet loner on the edge of everything. When scientists said it no longer counted, it felt personal, as if something sacred had been rewritten without asking. Across the world, petitions were signed, T-shirts were printed, bumper stickers declared, "Pluto is a planet in my heart." In Flagstaff, Arizona, where Pluto had been discovered, people held candlelight vigils. At planetariums, guests left notes and drawings, some angry, some mournful, many simply confused. Why? They asked. Why does it matter how we label it? But it did matter. Not just because of science, but because of the way we build stories out of the stars. Science, by its nature, moves forward. It adapts to new data. It refines its definitions as our understanding deepens, and from a technical standpoint, the reclassification made sense. Pluto's orbit is chaotic. It crosses inside Neptune's path. It's part of a wider belt of icy worlds. It didn't quite behave like the others, but logic is not the same as meaning. And when a planet is stripped of its title, it's not just a change in nomenclature, it's a shift in identity, not for Pluto, but for us. The term dwarf planet was intended to clarify, not diminish. It placed Pluto in a category with other round, orbiting bodies that hadn't cleared their paths. Eris, Haumea, Makemake, and others. But the name itself felt like a slight. Dwarfs are smaller, lesser, not quite. The language, however unintended, carried weight. And in that weight, Pluto seemed to shrink in the public eye, not in size, but in stature. Even within the scientific community, the decision wasn't unanimous. Some astronomers boycotted the vote, calling it premature. Others pointed out that the term "cleared the neighborhood" was vague and dependent on time and location. After all, even Earth shares its orbit with asteroids. Could any planet truly be alone in space? Debates raged in journals and classrooms. Panels formed, articles circulated. Some called for a redefinition of the redefinition. Others proposed alternative models that would expand the number of planets rather than reduce them. One model, called the geophysical definition, would include any round object not undergoing nuclear fusion, which would restore Pluto's planetary status and add dozens more. But for most people, none of that mattered. Pluto had been a planet for generations. It had a name, a place, a personality. It was the little world at the edge, the final stop in the solar system before the stars began. Stripping it of its title didn't feel like clarification. It felt like erasure. And yet, Pluto remained. It didn't change. It still orbited the sun. It still danced with Charon. It still spun slowly in a tilted, elongated path through the frozen dark. It didn't know it had been demoted. It didn't know it had been defended. The story of Pluto's fall from planet status is not just a story about science. It's a story about language and memory and the way we tie emotion to the things we learn as children. About how we assign identity to distant rocks because they give us a sense of place in something too large to hold. Pluto may be small, but in the hearts of many, it never stopped being part of the family. Not because of its orbit, not because of its mass, but because we had already made room for it in our imagination. And once something lives there, names are just noise. In 2015, after more than 9 years of silent travel, a spacecraft the size of a grand piano passed within 12,500 kilometers of a world we had never truly seen. New horizons had crossed the solar system, past the orbits of planets and moons and gas giants, chasing a dot that for generations had remained a mystery. And in one perfect moment, it looked back and captured something no telescope on Earth had ever revealed. A portrait of Pluto in sharp, intricate detail. What it sent home was not just data. It was a revelation. A world so strange, so beautifully alien, that it rewrote our imagination in an instant. On the surface of this cold and distant world was a shape that caught everyone's attention. Smooth and pale, stretched across the equator like a frozen sigh, lay a bright region that looked unmistakably like a heart. Its left lobe wide and curving, its right side rugged and textured. Against the darker, rust-colored terrain that surrounded it, the heart stood out like a beacon. A symbol not just of geological interest, but of something else. Something we couldn't quite name, but could feel. Pluto, the forgotten, the distant, had a heart. It was named Tombaugh Regio, in honor of Clyde Tombaugh, who first glimpsed Pluto through the flicker of shifting stars in 1930. But within that larger region, the smooth western lobe earned its own name, Sputnik Planitia. An icy plain roughly 1,000 kilometers across, filled with frozen nitrogen and carbon monoxide, resting within what appeared to be a massive ancient basin. From above, it looked peaceful, unscarred. A flat field of faint ridges and bright light. And yet, something was strange. There were no craters. Not a single obvious impact scar marked its surface. Not even the tiny pinpricks that usually pepper the outer solar system's icy worlds. In a place bombarded by cosmic debris for billions of years, that absence was impossible to ignore. Craters are the default signature of time in the solar system. They mark age, the way tree rings mark growth. The more scars, the older the skin. But Sputnik Planitia was smooth, undisturbed, as if it had been wiped clean. This region wasn't just frozen, it was young, geologically young, which meant something astonishing. Pluto, in all its smallness and distance, wasn't just a relic, it was active. No one had expected that. Before New Horizons, Pluto had been imagined as a frozen fossil, a quiet, dead rock drifting in the deep, too small to retain heat, too distant to stir. But the plains of Sputnik Planitia told a different story. The lack of craters suggested a surface no more than 10 million years old, and possibly even younger. In planetary terms, that's like finding fresh paint on the walls of an ancient ruin. Even more astonishing was the pattern that rippled across its surface. Subtle polygons, some stretching dozens of kilometers wide, tiled the plain like a giant cracked window. These weren't impact features or erosion marks. They were convection cells. Rising and sinking patterns formed as heat from Pluto's interior caused the nitrogen ice to slowly churn, like pancake batter warming on a cold griddle. Beneath the surface, something was stirring, gently but undeniably. In a place so cold that nitrogen becomes rock, Pluto was moving. The heart, it turned out, was not just a metaphor. It was a clue, a geological expression of warmth, activity, and memory. It hinted at a planet with enough internal energy to reshape itself, perhaps from radioactive decay in its rocky core, perhaps from tidal interactions long ago with its moon Charon, perhaps from something else entirely. But it was clear that Pluto was not finished. It was not still. Around the edges of Sputnik Planitia, darker terrain collided with the plain like waves meeting ice. Mountains of water ice towered above the smooth basin. Sharp, angular blocks rising as high as the Rockies, floating in a sea of frozen nitrogen. These mountains didn't erode. They didn't crumble. They stood like islands caught mid-drift, scattered across the plain in a frozen stillness that masked a slow, creeping dance. The basin itself was deep, perhaps 4 kilometers below the surrounding terrain, and shaped like an ellipse, suggesting it might have been formed by a massive impact long ago. If so, it wasn't just a scar. It had become a canvas, reworked and repurposed into something alive with movement. The presence of such an active region on Pluto shattered assumptions. It suggested that the internal heat required to drive geological change could exist even in small, icy worlds. It meant that distant frozen bodies might not be dead ends of planetary evolution, but chapters still being written. Pluto's heart wasn't just a standout feature. It was a door, opening onto a new kind of planetary science, one where the outer solar system became a place of process, not just preservation. More than anything, though, the heart resonated. It gave Pluto a face, a symbol, something unmistakable and unforgettable. Scientists called it Sputnik Planitia, but to almost everyone else, it was simply the heart of Pluto. It appeared on posters, shirts, jewelry, and in the soft corners of people's thoughts. The lonely little world with a heart. It didn't matter that it was made of nitrogen ice or stretched across a billion-year-old basin. It mattered that it was there. Real, beautiful, unlooked for. Before New Horizons, Pluto was an idea. After it, Pluto was a place. And in that place, at the edge of sunlight, lay something no one had expected. A plain of soft ice, smooth as sleep, ancient and young all at once, a heart in the cold. Not beating, not warm, but present, quiet, and unforgettable. Pluto's landscape is not what we were taught to expect. It is not the distant, featureless ball of static frost once imagined in the margins of old science books. It is jagged and strange, alive in the quietest sense. Nowhere is this more clear than in its mountains. Sharp, towering structures that cast long shadows across a frozen world, sculpted not from stone or fire, but from water ice, hardened by impossible cold. On Earth, water shapes the land by erosion. On Pluto, it is the land, standing upright in silence like ancient monuments, unmelting and unmoving for millions of years. Among these giants are the Tenzing Montes and Hillary Montes, named in honor of the first humans to summit Everest. The names are fitting, not just for their nod to Earth's tallest peak, but for what they evoke. Daring, remoteness, elevation beyond the ordinary. Pluto's peaks reach up to 3,500 meters, some even higher. They rise abruptly from the smooth plains of Sputnik Planitia, like a mountain range that lost its way and stumbled into the wrong planet. Their edges are jagged, their faces sheer, as if carved quickly and left untouched ever since. These mountains are made of ice, but not the kind that melts in your hand. Pluto's average surface temperature hovers around -230 degrees Celsius. At that level of cold, nitrogen becomes soft and pliable. Carbon monoxide freezes solid, and water ice transforms into something like granite. It is firm, unyielding, capable of bearing the weight of a mountain without collapse. In this world, the familiar rules of material and form bend. Ice is no longer delicate. It becomes the bones of the planet. But how did these mountains rise? Pluto is small, barely 2/3 the width of our moon, and lacks the kind of gravitational heft that usually drives planetary geology. On Earth, mountains form where tectonic plates collide, crumpling and folding under pressure. On Mars, they rise from ancient volcanic eruptions. On Pluto, the mechanism is still uncertain. There are no clear tectonic boundaries, no smoking calderas or obvious rift zones. And yet, here the mountains stand. Some scientists believe these ice peaks formed when the surface fractured, perhaps from the slow contraction of the planet's interior as it cooled, or from the freezing and expansion of an internal ocean. As the outer layers of Pluto shifted and cracked, chunks of rigid water ice may have been thrust upward, exposing their flanks to the open sky. Over time, erosion here would be minimal. There is no wind to carve away the edges, no liquid to smooth the slopes. So the mountains remain sharp, as if newly formed, their outlines preserved in deep time. The presence of such dramatic structures raises a deeper question. How could Pluto, so far from the Sun, still have the energy to reshape itself? The answer may lie within. Beneath the icy crust, there may be warmth. Not warmth in the way we know it. No lava, no bubbling magma, but a hidden store of internal heat, left over from the planet's birth, or slowly released by the decay of radioactive elements in its rocky core. This residual energy might be just enough to maintain a layer of slush or even liquid beneath the frozen shell, providing the movement needed to drive uplift and deformation. If that's true, then Pluto may have a kind of tectonics, not identical to Earth's, but its own quiet version. Shifts not in stone, but in ice. A slow, creeping rearrangement of the surface, guided by an internal world we still haven't fully seen. It's a reminder that geology isn't exclusive to big planets or warm ones. It's a language spoken in creeks and stretches, wherever material can move under pressure and time. The mountains themselves seem to sit in clusters, not arranged like the long, winding ranges of Earth, but more like islands cast into a sea. Some appear partially buried, others isolated on their own, surrounded by the vast flatness of the nitrogen plains. They seem caught mid-gesture, as if reaching toward something before freezing in place. In the quiet cold, they wait, and because nothing on Pluto erodes quickly, they may wait for another 100 million years. New Horizons offered only a brief flyby, a passing glance, but in that moment, it revealed a world far more complex than anyone had expected. The surface of Pluto told a story not of death, but of resilience. A place where mountains of water ice hold their ground against eternity, where internal heat whispers upward to crack the crust and raise peaks in a sky that never sees the sun rise high. These mountains are not just features. They are symbols of endurance, of motion in the stillest place, of a planet that refuses to be frozen in time. Tenzing Montes, Hilary Montes, names carved not into stone, but into ice. And through that ice, a message that the universe never stops building, even on the edges of light, even in the cold, even here. Pluto, for all its silence and distance, has a sky, not the kind we're used to. No clouds drifting in familiar shapes, no blue dome warmed by a golden sun, but a fragile veil of gases clinging delicately to a world too small to hold them for long. It rises just a sliver above the surface, barely an echo of an atmosphere. And yet it does something remarkable. It scatters sunlight. It glows. And when New Horizons looked back at Pluto after its closest approach, it saw something no one expected. A soft blue halo tracing the curve of the horizon. A world of ice with a sky that snows blue. The color comes from haze. Tiny particles suspended in the thin nitrogen atmosphere, floating like dust in a sunbeam. These haze layers stack themselves in sheets, dozens of them, forming a soft gradient that reaches up more than 200 kilometers above the surface. Each layer is the result of complex chemistry that begins high above, where solar ultraviolet light collides with methane molecules and cracks them apart. What follows is a cascade of reactions, a molecular dance in the emptiness. building more and more complex hydrocarbons. Some invisible, some golden, some deep red. Eventually, these molecules grow heavy enough to fall. As they descend, they clump together, coagulate, and become what are known as tholins, an old word for a new kind of matter. Tholins are not a single substance, but a family of organic compounds, born in the cold, shaped by sunlight, and dusted across the surface of distant worlds. On Pluto, they settle onto mountains, into valleys, and across plains, painting everything with subtle rusts and reds. But before they land, they drift through the sky, scattering blue light just like air molecules do on Earth. That's what New Horizons saw when it looked back. Not just a planet, but a world with sunsets. A pale atmosphere lit from behind, glowing blue around the edges like the thinnest breath of air holding its shape. It was a view no one had imagined. Until then, Pluto's atmosphere had been measured, inferred, hinted at through stellar occultations and telescopic spectra. But this was different. This was visual, emotional. It gave the dwarf planet a kind of intimacy it had never had before. A face, a mood, a sky. But this atmosphere is not permanent. It's not thick enough to remain anchored forever. Pluto's gravity is weak, barely able to keep a hold on its own breath. And so, slowly, steadily, the atmosphere leaks. Molecule by molecule, it drifts into space, carried off by solar winds and time. Some of it escapes completely. Some freezes out onto the surface, especially as Pluto moves farther from the sun in its long elliptical orbit. Winter on Pluto isn't just colder. It can erase the sky itself. Because the planet's orbit is so stretched, it takes 248 Earth years to circle the sun, and as it moves, its distance varies dramatically. At its closest, or perihelion, it receives enough sunlight to warm the surface slightly, causing frozen nitrogen to sublimate, turning directly from solid to gas, and build up a temporary atmosphere. At its farthest, aphelion, the sun is little more than a bright star in the sky, and the atmosphere can freeze out almost entirely, falling as frost and snow until the next season returns. This means Pluto's atmosphere is seasonal, on a scale we're not used to. Its climate breathes in centuries, not months. When New Horizons visited, Pluto had just passed perihelion and was still enjoying the extended warmth of that rare close approach. The atmosphere was swollen, active, alive with haze and light. But even now, it may already be thinning, the sky pulling itself back toward the ground, preparing for a century of deepening cold. And then there is the snow, not the kind that falls in flakes through thick clouds, but something quieter, lighter. The haze particles, after drifting and growing, may settle slowly, becoming a kind of snowfall, not of water, but of hydrocarbons. In Pluto's gravity, this descent could take hours or even days, gentle and slow, like dust motes drifting in still air. Some of it might sublimate before ever reaching the ground. Some might freeze onto the peaks of mountains, forming bright caps, or gather into the hollows of ancient craters. It is snowfall that almost forgets to land, a snow that exists between the sky and the surface, suspended in uncertainty. The high elevations on Pluto, especially near the bright region of Cthulhu Macula, show signs of this. Pale ridges, light dustings, brightness where the tholins have not yet darkened the surface. It's as if the mountains are catching the sky as it falls, trapping pieces of the atmosphere before they vanish again into sunlight or frost. Scientists believe the cold trapping of volatile ices, combined with this delicate snow of haze particles, might explain the varied albedo, how some regions reflect more light than others. It is climate, sculpted not by storms, but by stillness. And still, the haze persists. It drapes the planet in soft gradients. It colors the horizon in pastels. It carries in it the story of atmospheric chemistry, solar interaction, and the fragile balance between escape and return. It gives Pluto something quiet and rare, an emotional resonance. Because for a world so far away, so small and cold, to have a sky that glows blue and snows softly into silence. It feels like a kind of magic, a reminder that even the most unlikely places can hold beauty, that even where the sun barely reaches, light can still be scattered, color can still bloom, and snowfall can still fall, even if it never quite touches the ground. Pluto does not move through the dark alone. Around it spin 5 companions, moons, small and strange, each with its own path, its own secrets, its own rhythm. These aren't the polished, spherical satellites of the inner solar system. They're more like fragments of story, rough-edged and unpredictable, orbiting a world that was itself nearly forgotten. Together, they form a kind of family, tied not just by gravity, but by an origin wrapped in collision and chance. And at the center of that family is Charon, the largest, the closest, and the one that changes everything. Charon is half the size of Pluto, not a tiny moon trailing behind a dominant planet, but a near equal in mass and presence. They orbit each other in a way that breaks the usual hierarchy. Instead of Pluto standing still while Charon circles around, both bodies move around a shared center of gravity, a point in space that lies outside of Pluto itself. That center is known as the barycenter, and because it floats between them, the Pluto-Charon system is sometimes called a binary planet. 2 worlds locked in motion, turning forever in sync. This lock is more than orbital, it's tidal. Over eons, Pluto and Charon have become gravitationally bound in a dance so precise that the same sides of each body always face one another. Pluto never sees Charon's far side. Charon never sees Pluto's. They are fixed in their embrace, turning together through the Kuiper belt like figures carved into a music box, spinning not around each other, but with each other. And Charon is strange. Its surface is covered in shades of gray and fractured by deep chasms. One canyon system, stretching over 1,000 kilometers long and several kilometers deep, cuts across the moon like a scar. It is far larger than the Grand Canyon and hints at a history of internal expansion, perhaps the cracking of an icy shell above a once liquid ocean. Near the North Pole, a broad reddish cap stains the surface with color not seen elsewhere on Charon. It might be tholins, created by methane escaping from Pluto, migrating across space and freezing onto Charon before being chemically altered by ultraviolet light. The pole becomes a kind of chemical canvas, painted slowly by the breath of another world. Beyond Charon, farther out and smaller by far, are Nix, Hydra, Kerberos, and Styx. These moons are irregular in shape, more like spinning shards than spheres. They tumble rather than rotate smoothly, caught in gravitational tugs from Pluto and Charon that twist their movements into a kind of controlled chaos. Unlike Earth's moon, which presents the same face to us at all times, these moons spin unpredictably, their axes shifting over time. If you stood on one, though you couldn't, you'd never see the same sky twice. Hydra and Nix are the larger of the 4, but even they are tiny, only a few tens of kilometers across. Their surfaces reflect surprising amounts of sunlight, suggesting they are coated in relatively fresh ice. They are distant, cold and bright, lit faintly by a sun that is just a dot in the sky. Kerberos and Styx are smaller still, faint and difficult to study even during New Horizons' brief visit. What little we know suggests they too are icy, irregular, and part of the same broken lineage. Together, these moons likely formed from a single ancient event, a massive collision billions of years ago, when a proto-Pluto was struck by another large body in the young Kuiper belt. The impact ejected debris into orbit, and from that ring of material, Charon and the smaller moons coalesced. It is the same kind of origin story believed to have formed Earth's moon, though on a smaller and colder stage. The system is a monument to aftermath, a structure built not from quiet growth, but from violence that resolved into balance. What makes the Pluto system unique is how much it defies expectations. Pluto is no longer classified as a full-fledged planet. and yet it commands a complex, multi-moon system. It has a binary partner in Charon, a shared orbit around a barycenter, and smaller satellites whose motions are dictated by the gravitational pull of not one, but two central bodies. The result is a network of interactions, orbital resonances, and tidal exchanges that create movement more intricate than clockwork. The smaller moons, for instance, are caught in resonant orbits that keep them from colliding, but never quite stabilize them. Styx, Nix, and Hydra all move in ratios relative to Charon's orbit, echoing patterns found among the moons of Jupiter, but with less certainty. Their spins are irregular, their orbits wobble. Some even appear to flip as they orbit, rotating end over end, the way a tossed baton spins through the air. It is motion with memory, but no simplicity, a system on the edge of order, and all of it exists in the deep quiet beyond Neptune, where sunlight fades to a distant glimmer and the solar wind slows to a whisper. The Pluto-Charon system is not a place where life as we know it could flourish, but it is a place where nature has written complexity into the margins, a world with a companion so large it changes the definition of moon, a collection of satellites that do not behave, a red pole, a deep canyon, a dance of gravity that never ends. To look at Pluto is to see something unexpected, a dwarf planet with the depth of a major one. But to understand Pluto, you have to look at what follows it, what turns around it, what it carries through the dark. Its moons are not just background. They are pieces of its history, clues to its violence, echoes of its past. They are messengers of a system built on collision and balance. And they remind us that even in the farthest reaches of the sun's domain, worlds do not exist alone. They bring company with them, and sometimes that company holds mysteries of its own. Out here, the light is not gone. It is simply slower, softer. By the time it reaches Pluto, the sunlight has traveled for more than 5.5 hours, crossing nearly 4 billion miles of empty space. What arrives is not the fierce brilliance we know on Earth, but something thinner, something gentler, like a memory of warmth rather than warmth itself. Shadows are long and delicate, and the daylight carries the quality of late evening, even at noon. You could hold out your hand, and instead of being bathed in light, you'd find it faintly outlined, like the silhouette of something fading. This distance shapes everything. It defines the rhythm of Pluto's life, the pace of its years, the slowness of its change. The average distance from the Sun is around 3.6 billion miles, but that's only a midpoint. Pluto's orbit is elongated, stretched into an oval that brings it closer to the Sun at perihelion and flings it far away at aphelion. At its nearest, Pluto is about 2.7 billion miles from the Sun, closer than Neptune for a brief time. At its farthest, it's nearly 4.6 billion miles away. This orbit doesn't just mark time, it bends it. A full revolution takes 248 Earth years. No one alive has seen a full Plutonian year. It has been less than a century since its discovery, which means Pluto has not yet completed even a single trip around the Sun since we found it. Every season there stretches for decades. A spring might last longer than a human life. A winter could settle over the surface for 60 years, and the transition between them is slow, gradual, almost imperceptible. Change here does not happen in weeks or months. It happens in generations. Because the orbit is so eccentric, the seasons on Pluto aren't symmetrical. It spends more time at the distant end of its orbit, where the Sun is a cold glimmer, and less time at the close end, where it receives enough heat to awaken. At perihelion, some of the surface ices begin to sublimate. Nitrogen, methane, and carbon monoxide turn directly from solid to gas, forming an atmosphere that blooms briefly into existence. The pressure rises, and winds may stir, shifting frost from one region to another. But as the orbit carries Pluto outward again, the Sun shrinks, the warmth fades, and the gases fall back to the ground, refreezing into silence. It's like a breath held for centuries. This rhythm of retreat and return defines the landscape in ways we are only beginning to understand. Ice migrates across the surface, accumulating in some regions, vanishing from others. Mountains may be reshaped not by weather in the traditional sense, but by the slow crawl of frost across their faces over decades. Valleys deepen, not from flowing rivers, but from the weight of accumulating snow that isn't water. These are not seasonal changes as we know them, but transformations painted in the palette of deep time. Even the sky changes. The thin atmosphere that rises during the warm season eventually collapses again, falling as snow or frost. What was once a glowing blue haze becomes clear again, until the next perihelion returns to rouse the planet. There are no storms, no lightning, no thunderclaps, only the hush of gases condensing, the whisper of change barely audible across centuries. It is not silence, but the slowest kind of weather. And yet, even in this distance, the sun still holds Pluto in its grasp. Its gravity reaches across all that space, pulling the dwarf planet along its elongated path, keeping it from flying free into the interstellar dark. That path is tilted too. Pluto's orbit is inclined relative to the rest of the solar system, as if it were never quite aligned with the other planets, never quite part of the same story. It moves in its own plane, crossing above and below the orbital highway carved out by larger worlds. A drifter, bound to the sun but moving at a slant, like a comet that decided to stay. At aphelion, the light is dim enough that midday on Pluto would seem like twilight on Earth. Not darkness, exactly, but not daylight either. You would still cast a shadow. You could still see the outline of hills, the glint of ice. But the world would be wrapped in a kind of permanent dusk, as if the sun had just dipped below the horizon and decided to pause there, never fully setting, never fully returning. The surface would glisten faintly, each crystal of frost catching the meager light and scattering it in silence. And in that silence, there is a kind of peace. No traffic of asteroids, no storms of dust, no collisions or chaos. Just the gentle arc of a frozen world circling a star it can barely feel, following a path set long ago, with patience no living thing could match. The darkness between Pluto and the sun is not a void. It is a canvas stretched thin, holding light that takes its time. We often imagine the outer solar system as empty, but that's not quite right. It is not absence. It is distance. Space that humbles, that slows, that cools every impulse. Out here, light does not dazzle. It endures. It travels without urgency, illuminating a world that waits with the stillness of deep snow. And in that waiting, Pluto reveals a truth we don't often consider, that even in the farthest corners of our system, the sun still shines. Dimly, yes, but truly, and always. For most of human history, Pluto was little more than a smudge, a flicker on photographic plates, a dim, shifting dot moving against a background of stars. It was guessed at, argued over, imagined, but never truly seen. Its features were mysteries, its color debated, its moons too faint to resolve. Even with powerful telescopes, it remained elusive, shrouded in distance and time. We knew it was there, but we did not know it. And then, in the summer of 2015, a spacecraft the size of a piano changed that forever. New Horizons was never meant to be fast. It was meant to be first. Launched in 2006, it became the fastest spacecraft ever sent from Earth at that time, racing away from our planet at over 36,000 miles per hour. Its destination was farther than any mission had dared aim for as a first encounter. No orbit, no landing, no return, just a flyby, a single, fleeting moment of proximity. Less than 24 hours, after nearly a decade of travel through the dark. It was the kind of mission that required patience measured in years and precision measured in seconds. The team had only one shot. Pluto is small, moving fast, and far away. a narrow target at the edge of everything. There could be no course corrections at the last minute, no second attempts. New Horizons had to hit its mark at exactly the right time, with exactly the right orientation, or the opportunity would be lost. For months before arrival, the spacecraft was asleep, drifting silently. And then, slowly, it began to wake. Even before the closest approach, the images started coming in, blurry at first, like dreams trying to form. But each day they sharpened. Pluto, once only a whisper of light, began to grow in the frame. A disk, then a globe. Features emerged. Light and dark patches, hints of terrain. Scientists gasped at the first clear glimpse of the heart-shaped region that would later be named Sputnik Planitia. It was unexpected, smooth, bright, beautiful. The world we thought we knew was already something else entirely. When the spacecraft finally reached its closest point on the 14th of July 2015, it was a kind of choreography. Instruments whirred, cameras snapped, sensors collected data on everything they could: surface chemistry, temperature, atmosphere, magnetism. But New Horizons couldn't transmit anything in real time. It was too far away. Instead, it recorded everything on board, storing it like memories, to be sent later at the speed of radio waves, crawling through billions of miles of emptiness. For Earthbound listeners, that meant delay. The data streamed back slowly, bit by bit, like water through a straw. It would take over a year for all the information from that single day to make its way home. Each image was a postcard from the edge, arriving long after it had been written. But when they came, they changed everything. Pluto, it turned out, was alive in ways no one had imagined. Its surface wasn't ancient and cratered beyond recognition. It was dynamic. Some areas were young, almost shockingly so, free of impact craters, reshaped by internal processes that hinted at heat and motion. There were mountains made of ice, plains of frozen nitrogen, hazes in the sky, glaciers slowly creeping across basins. It was not a dead rock drifting at the edge of the solar system. It was a world with weather, with change, with stories etched into every ridge and valley. The heart-shaped feature, so perfectly positioned, it seemed staged, became an icon almost instantly. But it wasn't just symbolic, it was scientific. Half of it, the Sputnik Planitia Basin, appeared to be a massive impact site later filled with volatile ices. It acted like a cold trap, collecting frozen nitrogen and carbon monoxide, forming convection cells and slow glacier-like flows. This wasn't just terrain, it was movement, activity, the kind of processes we thought required bigger worlds, warmer ones, more central ones. New Horizons also revealed details of Pluto's moons with stunning clarity. Charon's canyon systems, Nix's unexpected brightness, Hydra's strange reflective surface. These were no longer footnotes. They were part of a complex system with history and interaction. The entire Pluto-Charon family now demanded a deeper look, a new respect. And beyond the images, the mission gave us something less tangible, but just as powerful: scale. It reminded us that exploration doesn't always require answers. It can begin with a single glance. That a spacecraft, hurtling past a distant world for only a moment, can redefine what a planet is, what a moon is, what a mission can mean. New Horizons didn't land, didn't linger, didn't return. It simply passed by, and yet it left behind a legacy that will last for generations. Even now, the echo of that flyby continues. Every new theory about planetary formation, every model of icy worlds, every plan for future missions to the Kuiper belt, they all trace their origins back to that moment, when we finally saw Pluto not as an abstract point on a chart, but as a world with its own weather, its own logic, its own kind of beauty. New Horizons reminded us what it feels like to see something for the first time. Truly see it, not as we imagined it, but as it is, and in that fleeting glimpse, we found wonder. Pluto appears quiet on the surface, a cold world of soft plains and jagged mountains, wrapped in frost and drifting through a distant part of the solar system where not much seems to happen. But quiet is not the same as still. Beneath the ice, beneath the familiar heart-shaped basin and the wind-swept haze, something stirs. Not in a violent way, not in a way we can watch directly, but in hints, in lines and patterns, in the way gravity shifts. In the silence, there is a pulse. It begins with Sputnik Planitia, the broad, gleaming expanse that makes up one half of Pluto's iconic heart. Smooth and vast, this nitrogen ice plain seemed, at first glance, like just another frozen stretch in a frozen world. But when New Horizons passed overhead and looked closer, it found more than ice. It found cells, huge, polygonal patterns, too symmetrical to be random, too young to be relics. These were convection cells, thought to be formed by slow churning of semi-solid nitrogen beneath the surface, like warm syrup rising and falling in a pan. It meant something was moving, something deep. Even more than that, something was pushing back. Sputnik Planitia lies in what appears to be a giant impact basin, a depression in Pluto's crust from a collision long ago. But what's strange is not just the impact, it's what filled the basin afterward. The plane isn't sunken anymore. It's slightly raised, sitting higher than it should, as if something inside Pluto has resisted the weight of the ice. And that suggests a hidden layer, something soft or buoyant, something like water. That's when the questions began to shift. Could Pluto, this small, distant, icy world, harbor a subsurface ocean? At first, it seemed unlikely. Oceans, we thought, belong to warmer places, or at least to larger ones with enough gravitational squeezing to keep the core heated. But Pluto has neither the mass nor the closeness to the sun that we associate with liquid water. And yet, the evidence kept mounting. Cracks on the surface stretched for miles, deep and long, like the skin of something cooling and expanding from within. That's the key. Expanding. If Pluto's interior had simply frozen solid over time, it should have contracted. The ice should have pulled inward, leaving wrinkles and compression. But instead, it stretches, as if something once liquid had turned to ice, expanding as it froze, reshaping the world from within. But what if that freezing never finished? Some scientists believe there may still be a layer of liquid water beneath Pluto's outer shell, kept warm not by sunlight or tidal forces, but by the slow decay of radioactive elements in the rocky core. Not a vast ocean like Earth's, not blue and swirling, but a briny, buried sea trapped beneath miles of ice, insulated, pressurized, protected by the very cold that seems to deny its existence. If true, it would make Pluto one of the growing number of ocean worlds in the solar system, alongside Europa, Enceladus, Titan, worlds that, despite their appearance, carry secrets in the dark. The gravity anomalies found around Sputnik Planitia support this idea. As New Horizons passed by, it measured tiny wobbles in Pluto's motion, revealing that the basin is denser than expected. That density, counterintuitively, could be explained by the presence of a subsurface ocean. Liquid water, denser than ice, might have pooled beneath the plane, rising to meet the depression from below. In that sense, the ocean isn't just hidden. It's active, responding to surface changes, resisting collapse, participating in the planet's slow, frozen dance. There are still debates. Some argue that any ocean Pluto once had must have frozen long ago, trapped by time and distance. Others point to thermal models and radioactive heating that could keep the water liquid for billions of years. The crust itself, thick, uneven, marked by strange patterns, offers no final answer, only clues. Like an ancient manuscript, some of its symbols worn and others freshly inscribed. One of the most compelling aspects of this hidden ocean isn't what it does, but what it suggests. Because if Pluto, so small and cold, can hold on to liquid water beneath its crust? What about all the other icy bodies scattered across the Kuiper belt? What about the moons of the gas giants? What about comets and dwarf planets that drift unseen at the edge of the solar system? We begin to realize that oceans might not be rare, they might be common. Tucked beneath surfaces we thought were lifeless, protected by cold, sustained by time, Pluto becomes a symbol of this quiet potential, a world that reminds us that motion doesn't always mean storms or eruptions. Sometimes it means slow upwellings of nitrogen. Sometimes it means cracks that widen over millennia. Sometimes it means a sea held in darkness, untouched by light, but not by change. And that change leaves its signature, not in noise, but in shape, in texture, in gravitational whispers. To wonder about the ocean beneath Pluto is to wonder about warmth in unexpected places. About life, maybe, not in the way we imagine it, but in the possibility of chemistry, energy, and time combining in a secret world. We don't know what lies beneath the ice. We can only read the signs left behind by something hidden, something ancient, something alive in its own slow way. And maybe that's what makes Pluto so haunting. Not just what we see, but what we don't. Not just the plains and peaks, but the silence between them. The gravity that hints, the cracks that speak. The softness of a world that should have been solid, and the possibility that inside it, water waits. Not rushing, not roaring, just waiting. From a distance, Pluto is not gray or white, like you might expect from a world made mostly of ice. It is not blank or monochrome, the way a snow-covered desert might appear. Instead, it holds color, a soft, rusted warmth that seems impossible at the edge of the solar system. That reddish-brown hue, delicate and diffuse, wraps around its equator like a belt, deepening in some regions and fading in others. It is not the red of fire or blood, but something gentler, weathered, muted. The color of age, of time stretched thin, of chemistry unfolding over billions of years beneath a distant sun. This color, though beautiful, is not skin deep. It is a clue, a surface whisper of complex chemistry shaped by light that barely reaches it. Pluto's surface is coated in a mix of methane and nitrogen ices, volatile substances that behave like liquids and gases depending on how the temperature shifts. And above that frozen terrain, sunlight, weak though it is, collides with the molecules that drift upward, breaking them apart, transforming them into something new. This dance of particles and photons, of ice and radiation, creates compounds called tholins. Tholins are not unique to Pluto. They appear on other cold worlds, on Titan, on comets, on the moons of Neptune and Uranus. But here, they find a stage large enough to stretch into subtle gradients. These organic molecules, complex chains of carbon and hydrogen, settle across the plains like dust, tinting everything they touch. They are not alive, but they carry the complexity we often associate with life. Formed from simple gases, sculpted by ultraviolet light, they turn a white world golden, then rose, then deep brown, where Pluto receives more sunlight, closer to perihelion, in its long, lopsided orbit. This process accelerates. The light breaks more bonds, triggers more reactions. The ices become darker, more stained, and in the shadows, where light is scarce and frost accumulates, the terrain brightens again. It becomes a mosaic, a map of sunlight's slow progress over centuries. A planet-sized canvas of chemical storytelling. The reddish band that stretches around Pluto's equator is not uniform. In some places, it deepens into rich, almost copper tones, especially near Cthulhu Macula, a vast, dark region that slinks along the lower hemisphere like a shadow that refuses to lift. Elsewhere, it fades into the pale tones of fresh ice, especially around Sputnik Planitia, where the nitrogen frost seems to gleam under the sky's blue haze. The contrast is striking, like bruises beside silk, like rust beside bone. It tells of a surface in flux, a world that isn't static even when frozen. These colors also shift with the seasons, though seasons on Pluto stretch for decades. As the sun retreats, the atmosphere collapses and frost creeps back across the terrain, brightening it, smoothing it, hiding the older tholins beneath fresh layers of ice. When Pluto draws closer again, the atmosphere thickens slightly, thins again, and the ices begin to sublimate. The older colors return, baked deeper by radiation. The red is not constant. It breathes with the orbit, changing its tone depending on where the planet is in its long ellipse. Even on smaller scales, the terrain speaks in color. Some craters hold on to their brightness, ringed with pale ejecta that hasn't yet darkened. Some mountains reflect more light, standing like frozen peaks above the more heavily weathered plains. And at the edges of Charon-facing regions, you can sometimes spot transitions, places where the chemistry shifts subtly, where the interaction between Pluto and its largest moon leaves an imprint even on the pigment of the surface. Charon itself is mostly gray, but its pole bears a stain of red, thought to be tholins too, captured from Pluto's escaping atmosphere and frozen onto Charon's ice. A reminder that color, on these distant worlds, is not just decoration, it's movement, it's memory. The remarkable thing is not just that Pluto is colorful, but that it is so delicately so. The hues are not garish or loud. They don't leap from the surface. They glow. They lean into the light, rather than fighting it. They hold emotion, somehow. Like a painting left too long in the sun, there's warmth in the brown, depth in the red, and silence in the pale, untouched frost. Before New Horizons, we didn't expect this. We imagined Pluto as pale, maybe bluish, maybe dull. But the truth was more complex and more beautiful. What we found was not a world of blank ice, but one that wears its chemistry like a memory. Each tint, each smear of rust or cream or blush is a record of interaction, of sunlight touching methane, of radiation shaping carbon, of frost hiding and revealing what lies beneath. Color becomes a map, not just of terrain, but of time. The places that are darker may be older, the brighter patches may be newer, resurfaced by slow atmospheric snow, and in between, gradients appear, places in transition where change is still underway, not fast enough for eyes to see, but fast enough for history to notice, and all of it unfolds in silence. No rushing winds to erode, no rainfall to wash away, just light and chemistry, dancing across the surface of a world that doesn't need speed to tell a story. A world that whispers its hues in thin air and waits for someone, someday, to come close enough to see. Pluto's colors are quiet, but they are not faint. They endure. Pluto doesn't have weather in the way Earth does. There are no rainstorms, no thunderstorms, no roaring hurricanes or howling wind systems circling its poles. If you stood on its surface, you wouldn't feel a breeze against your cheek. The air is too thin, far too delicate for that. And yet, weather still happens there. Subtle, ghostly, and stretched out across decades. It's the kind of weather that speaks more in sighs than shouts. A climate that moves in a language so slow and soft, it takes patience to understand. At its closest, Pluto's atmosphere is about 100,000 times thinner than Earth's. It's not even dense enough to ruffle a feather. Made mostly of nitrogen, with traces of methane and carbon monoxide, it clings to the planet with the faintest pressure, just enough to lift a veil of haze above the horizon. There are no clouds in the way we imagine them, but there are layers, 30 or more. Rings of haze stacked in the air like ghost sheets, each one catching the sunlight at a slightly different angle. These layers scatter blue light, giving Pluto a sky that glows with unexpected color, especially at sunrise and sunset. For a world so far from the sun, the sky still finds a way to glow. But this atmosphere is not always present. It comes and goes, depending on Pluto's place in its orbit. As it moves closer to the sun during its 248-year journey, sunlight warms the surface just enough to vaporize some of the frozen nitrogen and methane. That gas rises, forming the thin atmosphere we now know. As Pluto recedes again, moving toward aphelion, the sunlight weakens, temperatures drop, the gas recondenses, falling back to the ground like frost, thickening the crust with a fresh layer of ice. The entire atmosphere collapses, not suddenly, but inevitably. Pluto breathes in centuries. This cycle of atmospheric collapse and rebirth is unlike anything we experience on Earth. It's not daily or seasonal in the way we understand time. It's generational. An entire human life can pass while Pluto's atmosphere is in one phase, only to shift again after death. On Earth, we use weather as a way to measure our days, our moods, our plans. On Pluto, it's more like geology. Slow, structural, patient. Still, even in that thin air, there are movements. Winds, or something like them, flow horizontally across the plains, carrying haze particles and shifting frost patterns. These motions aren't strong enough to pick up dust or carve canyons, but they're real. Subtle gradients in surface temperature and pressure send gases gliding from one region to another. Sometimes these flows follow the curve of Sputnik Planitia, gathering in the cold trap at its center. The basin acts like a sink, pulling in vapor and laying down layer upon layer of nitrogen frost, sculpting the terrain with every freeze and thaw. Over time, these gentle flows help redistribute ice across the planet's surface, not evenly, but with preference. Certain regions get more exposure, more deposition, more erosion, not by windstorms, but by the whisper of invisible hands reshaping the skin of the planet across generations. It's erosion without movement, change without violence. And then there are the hazes, stacked, delicate, and strange. These layers are composed of tiny particles formed when ultraviolet sunlight breaks apart methane molecules high in the atmosphere. The fragments recombine into complex hydrocarbons, which then clump together and fall slowly toward the ground. As they descend, they scatter light, glowing softly in the dim sun. From above, they make the world seem wrapped in gauze. From the surface, they would give the sky texture, even in silence. This haze is not permanent. Like the atmosphere itself, it shifts with the seasons, thickening and thinning depending on how much sunlight Pluto receives. And yet, its presence is profound. It speaks of chemistry still at work, of interactions between light and matter happening in slow motion. It adds layers not just to the sky, but to our understanding. When New Horizons passed by and looked back at Pluto against the light of the sun, it caught something extraordinary. A halo, a glowing rim of blue light encircling the planet, scattered by the haze. It wasn't expected. It wasn't something anyone had dared to imagine. Pluto, a world of frost and silence, suddenly looked ethereal, like something imagined in a dream. The kind of image that doesn't need interpretation. It just lingers in the mind, beautiful because it exists at all. This atmospheric behavior, its appearance, disappearance, and delicate dance with frost, reminds us that weather does not always require storms to be significant. Sometimes, weather is a pause, a question, a breath. The climate on Pluto does not rush, it waits. It unfolds like a slow tide pulled by centuries. There are scientists who model these processes, who build simulations of how frost migrates across the surface, how haze settles, how gases swirl gently in the thinnest of breezes. Their models show cycles that stretch for hundreds of years, painting pictures of landscapes that darken and brighten, expand and retreat, not with the rhythm of days, but with the rhythm of epochs. The models do not end with certainty. They end with curiosity. We don't yet know what Pluto's atmosphere looks like today. Since New Horizons passed, it has moved farther from the sun. The atmosphere may already be collapsing again, or it may persist longer than expected. Observations from Earth can only tell us so much. The rest is inference, speculation, wonder. But even not knowing becomes part of the story. It means Pluto still holds mystery, still changes even when we're not watching. In a world where nothing should move, things move. In a place too cold for air, there is breath. In a silence too deep for weather, there are seasons that stretch longer than memory. Pluto teaches us that not all climates are loud. Some are slow enough to teach patience. Some speak in frost and light. Some drift, like Haze, too soft to hear, but too beautiful to ignore. The weather on Pluto doesn't shout. It waits. Charon isn't just one of Pluto's moons. It is, in a quiet, gravitational way, the other half of a story that can't be told without it. Most moons orbit their planet like children trailing behind a parent, pulled along by weight and mass and age. But Charon doesn't trail. It moves in step. Pluto and Charon orbit each other around a shared point in space, a balance so precise it holds them in a slow, synchronized dance. Not a hierarchy, but a partnership. From afar, they might look like a planet and its moon, but from up close, they resemble something else entirely. A binary world, a pair of companions circling each other endlessly, locked together by time and physics. Charon is massive compared to Pluto. At about half its diameter, it's the largest moon relative to its planet in the solar system. No other planetary pair has this kind of balance. It shifts the center of gravity outside of Pluto's surface, creating a system where both bodies wobble around an invisible point in space between them. They are always facing each other, tidally locked, one hemisphere forever watching the other. If you stood on Pluto's surface, Charon would never rise or set. It would hang in the same part of the sky for all time, unblinking and still. But Charon is far from featureless. Its surface tells stories in fractures and scars. Great canyons stretch across its crust, some of them many times deeper and longer than the Grand Canyon on Earth. These tectonic features suggest that Charon once changed shape, that it may have expanded as its interior cooled and froze, cracking the outer shell in vast, jagged lines. It's a frozen world, yes, but not a silent one. Its surface holds the memory of movement, of upheaval, of something shifting within and pressing outward until the surface broke open. At its north pole, Charon carries a stain, a reddish cap, visible even from orbit, unlike anything else on its gray, icy body. This color isn't natural to Charon itself. It is thought to be tholins, those complex organic molecules, rich in carbon, that form when sunlight interacts with gases like methane. But where would such gases come from in this airless place? The best explanation is Pluto. Scientists believe methane escaping from Pluto's thin atmosphere drifts outward, reaching Charon and settling at the poles during the long, frigid nights. There, in the darkness, it freezes, and when sunlight returns, it triggers the chemical reactions that form the reddish tholins, staining the ice like a memory left behind. It's a quiet kind of alchemy, one body breathing out, the other body catching its breath. They are connected not just by orbit but by chemistry. One paints, the other is painted. Even here, billions of miles from the sun, there is exchange, relationship, a slow sharing of materials and time. Theories about Charon's origin often lead back to Pluto's own birth. One prevailing idea is that a massive collision, much like the one that formed Earth's moon, created Charon. In this scenario, something struck young Pluto in the early solar system, a glancing blow that shattered part of its crust and sent debris into orbit. That debris eventually coalesced, pulled together by gravity, until it formed Charon. If true, then Charon is made of Pluto's own bones, born of the same material, shaped by the same violence. They are not just neighbors. They are kin. This idea is supported by their shared composition. Both Pluto and Charon are made mostly of rock and ice, in roughly equal parts, unlike many other planetary systems where moons tend to be either dense or porous, not both. Their densities, their chemistry, even their surface features, all suggest a linked history, a moment of chaos that bound them together forever. In this way, Charon becomes a window into Pluto's past, a remnant of an ancient impact, frozen in place, holding clues to a time before planets had settled into their final forms. Charon has no atmosphere, no weather, no haze. Its sky is black, unbroken by clouds or color. But this stillness allows for clarity. The surface preserves detail without erosion, keeping every impact, every crack, every layer exactly where it formed. It is a record keeper, a cold historian in orbit, circling its partner with unflinching patience. Where Pluto evolves with frost and light, Charon endures. It doesn't hide its past beneath shifting snow or atmospheric blush. It displays it plainly, worn into its surface, like scripture. And yet, Charon is not simply a relic. There's something intimate about the way it faces Pluto, always, as if it refuses to turn away. No spinning, no rotation to hide its face, just steady observation. From Pluto's surface, Charon would loom large in the sky, larger than our moon appears from Earth. And unmoving, it would cast no sweeping shadows, only quiet presence, like a guardian, like a reminder. It's easy to forget the beauty in quiet companions, the ones that don't shine on their own, but reflect the light of others. Charon does not blaze or dazzle. It holds, it watches, it remembers. It turns a face to Pluto and never looks away. Together, they defy the norms of planetary systems. Together, they orbit not in dominance, but in balance, not in brightness, but in story. Theirs is a relationship measured not in days or years, but in gravitational loyalty, in the poetry of shared mass and mirrored movement, and in the cold, dark outskirts of the solar system. That kind of connection might be the most remarkable thing of all. The solar system doesn't end at Neptune. It doesn't fall away into silence or emptiness the moment the last gas giant fades into the background. Beyond that orbit, past the great cold hush of space, there lies a kind of frontier, vast, slow, and strange. This is the Kuiper belt, a broad ring of icy remnants circling the sun like a forgotten echo of the early solar system. Billions of frozen bodies drift through this region, most too small to see, too distant to know. But among them are worlds, real ones, worlds with shape and motion and story. And Pluto, for all its uniqueness, is one of them. For decades, Pluto was thought to be the outlier, a lonely, distant planet at the edge of the solar system, orbiting far from the others with a tilt and eccentricity all its own. But then, one by one, other objects began to appear. Astronomers peered deeper into space and started finding more icy bodies, some small, some large, all beyond Neptune's orbit. It was as though a curtain had been lifted, and behind it was a crowd. Pluto wasn't alone. It was part of something bigger, part of a hidden belt, a disk of debris left over from the formation of the solar system more than 4 billion years ago. The Kuiper belt stretches from about 30 to over 50 astronomical units from the Sun, though its boundaries are diffuse and hard to draw. It's filled with icy bodies, fragments of rock and frozen gases that never formed into planets. Some of these objects are just a few kilometers across, tumbling slowly in the dark. Others are far larger, even rivaling Pluto in size. Eris, for example, discovered in 2005, briefly stole Pluto's planetary status in the public imagination. Haumea, shaped like a distorted egg and spinning faster than almost any other large body we know, dances through its own slanted orbit. Make, cold and remote, reflects just enough sunlight to shimmer faintly against the black. These are dwarf planets too, worlds in their own right, frozen and distant and strange. Pluto is one of them. A Kuiper belt object, or KBO, not an exception, but a participant. It shares the same kind of orbit, the same icy composition, the same ancient origins. In fact, Pluto is considered one of the largest and brightest of the KBOs, which makes it both an ambassador and a mystery. It's the one we found first, the one we knew best, until we realized how little we understood it. Its orbit, highly inclined and elliptical, dips in and out of Neptune's path but never collides, held in check by a delicate orbital resonance. It completes 2 orbits for every 3 of Neptune's, a mathematical harmony that keeps the two from ever drawing too close. And yet, even within this family of distant objects, Pluto is still different. It has a large moon system, with Charon so massive it creates a binary dance. It has a layered atmosphere, a beating geological heart, and mountains made of water ice. While other KBOs glint faintly in our telescopes, Pluto has shown us complexity. It has weather and color and topography. It isn't just a chunk of ice. It's a world with seasons and textures, a surface shaped by processes still ongoing. Many KBOs are thought to be the source of comets, when their orbits are perturbed by collisions or the nudges of passing stars. They can fall inward, racing toward the sun in long arcs. As they approach, their ices sublimate, forming the glowing tails that we see from Earth. These comets are time capsules, bringing with them the chemistry of the early solar system. In a way, they are the messengers of the Kuiper belt, delivering fragments of its story across billions of miles. Pluto may never become a comet, but it carries the same ingredients, the same ancient signatures. Some scientists believe the Kuiper belt holds clues to the solar system's early history, to the migrations of planets and the chaotic dances that once shaped orbits and flung worlds across space. Studying Pluto and its neighbors may help us understand why the solar system looks the way it does today, why certain planets ended up where they are, why others were cast out or never formed at all. It's a frozen fossil record, not in stone but in ice, preserving the chemistry and architecture of a time before Earth was born. But even in that shared origin, Pluto holds a place apart. Its story is human as much as it is planetary. It was the first of the Kuiper belt objects to be discovered, and for much of the 20th century, it stood alone in our minds, a tiny outpost at the edge of everything. People gave it personality, mythology, affection. When its planetary status was questioned, it wasn't just a scientific debate, it was emotional. Because Pluto was ours. We'd grown up with it, named it, watched it, and when New Horizons flew past and sent back images, they weren't just data, they were portraits. Suddenly, the vague dot became a place with mountains and plains and hazes and a heart-shaped glacier that seemed to answer every lonely human longing for recognition. Other KBOs exist, but none have shown us themselves the way Pluto has. So yes, Pluto is a Kuiper belt object. It is one of many, but it is also still Pluto, unique not only in science but in spirit. It was the key that unlocked the door to the outer solar system, the name that led us into the cold and crowded dark beyond Neptune. It was a mystery first, and now it is a home for our questions. Out there, in that dim and distant belt, other worlds are waiting, silent, cold, unknown. But Pluto, for a moment in time, turned and looked back, and we saw it. Time moves differently on Pluto, not just because it is far away, where the sun is barely more than a star and the light takes hours to arrive, but because the rhythm of its days and seasons beats to a strange, quiet drum. On Earth, a day is 24 hours, a fast spin beneath a yellow sun. On Pluto, a single day stretches out to 6.4 Earth days. The planet rotates slowly, deliberately, as if savoring each turn. It takes almost a week for the sun to rise, crawl across the sky, and set again. Nightfall is not a moment, but an event, long and drawn, deep and cold. But it's not just slow. Pluto's rotation is tilted, severely. Its axis leans at an angle of about 120 degrees, a strange kind of posture that sets it apart from almost every other world we know. Where Earth is modestly tipped, giving us the gentle sway of seasons, Pluto lies nearly on its side. It spins like a rolling ball rather than a top, turning retrograde, backwards compared to most of the planets, as if it's resisting the motion of the solar system, choosing its own quiet path instead. From the surface, the sun would rise in the west and set in the east, reversing everything familiar. This tilted world experiences seasons in slow, sweeping arcs that last for decades. As it moves through its 248-year orbit, the angle of sunlight changes dramatically, bathing one hemisphere in extended sunlight while plunging the other into darkness that can last for years. Winter on Pluto is not a matter of months. It's a commitment, and spring does not come quickly. The planet turns, yes, but the consequences of that turn are vast and lingering. And then there is Charon, always Charon, locked into this dance. Pluto's largest moon is not just a companion but a mirror, held in place by the same gravitational pull that freezes their faces toward each other. They are tidally locked, which means that from Pluto, Charon never moves in the sky. It hangs there, permanent and still, gazing down from the same position day after day, night after night, year after year. The same is true in reverse. From Charon, Pluto never shifts. They are caught in a slow, perfect orbit around a shared center of gravity that hovers in space between them. It's not a master-servant relationship, like most moons to their planets. It's more equal, a shared rhythm, a binary waltz across the dark. This partnership shapes everything. The gravitational tension between Pluto and Charon influences their surfaces, their tides, their very stability. It holds them in a balance that prevents the kind of chaotic tumbling seen in other moons. And yet, their influence spills outward. The smaller moons, Nix, Hydra, Kerberos, and Styx, are not so lucky. Their orbits are chaotic, pulled in different directions by the dominant pair. These moons don't spin in regular ways. They tumble, caught in unpredictable rotations, their days and nights ruled by disorder. They are like dancers without a fixed partner, spinning through the darkness, guided only by uncertainty. But Pluto and Charon remain steady. Their bond is a kind of gravity-forged trust, a stillness at the center of motion. Because Pluto spins so slowly, and because of the tidal locking, the view from its surface is unusually intimate. Charon's presence is constant. It casts no sweeping shadows, no phases or crescents. Just a gray, cratered face, frozen in place. For the people who grew up imagining Pluto as a lonely outpost, this revelation was startling. Pluto is not alone. It never was. It has company, close company, in a place we thought was empty. This rotation, this slow turn under a distant sun, shapes more than just time. It shapes climate, temperature, and even geology. The prolonged exposure to sunlight on one hemisphere causes frost to evaporate and migrate, reshaping the surface over decades. Shadows stretch endlessly across the ice. The heat of the sun, faint though it is, builds up slowly, melting and refreezing the surface in rhythms that last generations. A shadow isn't just a fleeting thing here. It's a place where ice stays for years, untouched by light. Scientists who study Pluto must translate their understanding of time into a different scale. Processes that might play out over days on Earth unfold over centuries on Pluto. A single rotation lasts nearly a week, a single year more than 2 human lifetimes. This is not a world for impatience. It teaches us to watch more slowly, to wait, to let things emerge in their own time. And through it all, the retrograde spin, the deep tilt, the slow pirouette beneath a dim star, Pluto moves. It rotates in defiance of simplicity, its orbit and axis and moons all tangled in a ballet that resists easy explanation. It is a system born of complexity, shaped by ancient impacts and sculpted by subtle forces. The motions we take for granted, sunrise and sunset, moonrise and fall, are rewritten here, reordered into something slower, stranger, and somehow more beautiful. Because Pluto's dance isn't just motion, it's memory. It carries the imprint of how it formed, how it collided, how it settled. It tells us not only where it is, but how it became. And even now, as it turns, so slowly, so quietly, we are still learning to listen to its rhythm, not as something foreign or remote, but as a different kind of music, composed in the long, cold stretches between the stars. There's grace in that, not in speed or symmetry, but in difference. In the stubborn orbit, the tilted axis, the slow and backward spin. In the quiet conversation between a planet and its moon, held not by speech but by gravity. And in the stillness of that shared gaze, as they circle one another through a darkness that only deepens, never dims. There's a story carved into every surface in the solar system, written not in words, but in wounds. Craters, those circular scars left behind by impacts long past, are how the universe keeps time. They are fossils of collisions, each one a frozen moment, when a piece of rock or ice struck a world and left behind a mark no atmosphere could erase. On planets without wind or rain or tectonic churn, those marks endure for billions of years. They don't heal, they accumulate. The more craters a surface has, the older it is. And when we first looked at Pluto in detail, this was one of the first questions we asked. How many scars does this distant world carry? When New Horizons swept past Pluto in 2015, what it saw surprised nearly everyone. Some regions were battered and old, pocked with overlapping craters that spoke of a surface unchanged for perhaps 4 billion years. But others, like the vast, smooth expanse of Sputnik Planitia, were nearly pristine, not just lightly cratered, but almost entirely unmarked. In a universe where impacts are constant and unrelenting, this smoothness is strange. It suggests something active, something erasing the past. It's not just the absence of craters that raised eyebrows. It's the contrast. One hemisphere could be a graveyard of ancient collisions, while another looks like it was smoothed over yesterday. This kind of patchwork youthfulness isn't something we expected to find on a cold, distant world long thought geologically dead. Yet there it was, a landscape telling two very different stories. On one side, the memory of violence. On the other, a curious silence. Crater counts aren't just about tallying holes in the ground. They're about building timelines. Every impact adds a layer of history, like rings in a tree. And when that history is missing, when the rings have been wiped away, it means something has been at work. On Pluto, something has resurfaced vast areas, possibly through slow convection in the nitrogen ice, or by deposition of atmospheric frost, or even by some form of cryovolcanism. Whatever the mechanism, it's recent on a geological scale, possibly within the last 10 million years. A blink in planetary time. Some craters we do see are chained together, clustered in lines that suggest secondary impacts, fragments of a larger object that shattered and struck the surface in a sequence. These patterns help confirm the age of a region, especially when compared to similar chains on other icy worlds. They tell us not just when something happened, but how. And yet, in the smoothest parts of Pluto, these signatures are missing too. No chains, no pitting. Just sweeping plains of ice, broken only by subtle ridges and troughs. There are also peculiarities in the distribution. In some places, craters appear where they shouldn't be, nestled into soft, eroding terrain that should have swallowed them long ago. In others, expected craters never appear. Models of impact frequency predict more marks than we observe. This raises questions. Are we misunderstanding the rate of collisions in the Kuiper belt? Or is Pluto's surface even more dynamic than we guessed? Perhaps both. Perhaps the outer solar system holds rules we have yet to write. What's even stranger is the difference between Pluto and Charon. While Pluto shows this mix of old and young, Charon appears more consistently ancient, especially across its northern hemisphere. It's pitted and scarred, with fewer signs of surface renewal. And yet even there, we find fractures and planes that suggest movement, maybe even cryovolcanic flows. The contrast between the two bodies, so close in space and time, is a reminder that even similar worlds can evolve along different paths. Crater mapping reshaped our understanding of Pluto's age and activity. It told us this wasn't a frozen relic, passively orbiting at the edge of the system. It was, and perhaps still is, alive in its own quiet way. The youth of some regions suggests internal heat, unexpected, mysterious, and perhaps residual from its formation, or driven by the radioactive decay of heavy elements trapped deep within. That heat, faint and buried, might be enough to soften the ice, to stir the surface, to renew. But there's also what we can't see. The parts of Pluto never photographed in high resolution, the hidden hemisphere not captured during New Horizons' brief flyby. We know it exists. We've glimpsed it in grainy images. But the fine details, the small craters, the subtle textures, they remain unknown. Somewhere in that unseen landscape may lie more clues, more missing craters, or more preserved ones. We can't say for sure. And so, the story is incomplete, like a book missing half its pages. Still, from what we have seen, the picture is already compelling. Pluto does not wear its history evenly. Some parts are ancient, others are young, and the boundary between the two is not always clear. It's a world in flux, not chaotic, but nuanced. It's reshaping itself, sometimes subtly, sometimes dramatically, erasing and writing over the past. Craters are the script, but Pluto is still editing. And in that quiet work of resurfacing, of change unfolding over millions of years, we're reminded that even the most distant, most overlooked places are not frozen in time. They evolve. They respond. They remember and forget. Pluto doesn't shout its story. It whispers it, buried in ice and absence, in shapes barely visible from billions of miles away. And one of its softest, most powerful whispers is this: what we don't see can matter just as much as what we do. Pluto's story begins in silence, not the quiet of stillness, but the chaos of a young solar system, thick with dust and stone and ice, a place of collisions and migrations, of paths not yet settled. This was a time before planets had names, before moons had orbits, when gravity pulled like a sculptor's hand across a mess of raw materials. Somewhere out there, in the cold and crowded outer reaches, something strange began to take shape. We don't know exactly how Pluto was born, but we know it wasn't simple. One leading idea is that Pluto came into being much like Earth's moon, through violence. A massive object, perhaps nearly as large as Pluto itself, might have slammed into the young protoplanet in a glancing, oblique collision. Not a shattering blow, but a devastating sideswipe, flinging debris outward into a spinning disk of icy rubble. From that spiral of remnants, a companion emerged. Charon. The sizes make sense. The math adds up, and the deep connection between the two. Their locked orbits, their shared center of gravity, feels almost too perfect to be a coincidence. But other theories press their fingers against the edges of that story. Some suggest that Pluto and Charon formed side by side, two bodies coalescing in tandem from the same cloud of icy material. This would explain their close match in composition, their gravitational dance, their intertwined history. Others wonder if Charon was captured, pulled in from a passing trajectory, and locked into orbit by a well-timed exchange of momentum. Capture, however, is a difficult act. It requires a third body, something to carry away the excess energy, something to make the chaotic precise. And in the far Kuiper belt, that kind of cosmic choreography may be rare. Yet Pluto is full of rarities. The more we study it, the more it seems to carry the fingerprints of early upheaval. The surface is young in places, old in others. The moons spin and wobble. The orbit is wildly tilted and elongated. These are not the signs of a quiet formation. They are signs of something shaped in disruption, then set loose into a system that kept changing. During the early days of the solar system, the giant planets, Jupiter, Saturn, Uranus, and Neptune, were not where they are now. They migrated. Slowly, over millions of years, their positions shifted outward or inward, like dancers adjusting in a crowded room. This migration stirred the outer regions into chaos. Objects were flung outward into the deep dark. Others were thrown inward, colliding with planets or falling into the sun. Pluto, small and distant, may have been caught in the shifting tides of this great rearrangement. It now orbits in resonance with Neptune, locked into a pattern where for every 3 orbits Neptune completes, Pluto completes 2. This gravitational handshake keeps them from ever colliding, even though their paths cross. It's a stable chaos, a negotiated balance, and it likely didn't happen by chance. Something about Pluto's orbit, its strange tilt and eccentric shape, is a fossil of that planetary migration. It may have been nudged, captured, or even rescued by Neptune's slow retreat into the darkness. This kind of resonance isn't just coincidence. It's a memory of how the solar system found its current shape, not through planning, but through conflict. Worlds bumped into each other. Orbits clashed and reformed. Pluto's placement, its distant, tilted track, isn't a sign of exclusion. It's the result of survival, and that survival is etched into its identity. Pluto doesn't look like the rocky inner planets. It doesn't resemble the gas giants either. It's something else. An icy hybrid of rock and frozen volatiles, shaped by collisions, colored by chemistry, and molded by time. It lives in a region filled with objects like itself, yet somehow it rose to become the most famous of them all. Maybe because it was found first, maybe because of its temporary claim to planetary status, or maybe because it resonates with us in a different way. A loner, an exile, a survivor. Charon's presence complicates and deepens the mystery. The binary system they form is unlike any other in the solar system. Their center of gravity lies outside both bodies, which means they orbit each other, not in the way Earth and Moon do, but in a truer sense of mutual revolution. That kind of relationship doesn't come easy. It's a sign of something fundamental, something ancient. Whether born together, shattered and reunited, or captured in a moment of chance, their bond has held. And beyond Charon, the smaller moons, Nix, Hydra, Kerberos, and Styx, float in strange, chaotic paths, suggesting they too were part of this formative event. Perhaps they are remnants of the same collision that formed Charon, or coalesced from the aftermath, like forgotten notes in a long song. They don't behave like typical moons. Their orbits are irregular, their spins unpredictable. They are pieces of a puzzle scattered and spinning, all of it. Pluto's composition, its orbit, its moons, tells a story of origin not in calm assembly, but in catastrophe followed by adaptation. A world that formed from the wreckage, not in the peaceful coalescence of dust, but in the wake of violence. And yet from that chaos came something intricate, a system of balance, of resonance, of quiet motion in a far corner of the sky. In many ways, Pluto is less a planet and more a time capsule. It carries with it the memory of how messy the beginning was, how the solar system wasn't born in neat rings and orbits, but in wild, unsteady motion. Everything about Pluto whispers this. Its strange tilt, its binary companion, its eccentric path through the Kuiper belt. It is the residue of turbulence, still spinning, and perhaps that's why it fascinates us. Not because it is perfect, but because it isn't. Because in all its eccentricity and exile, it carries the imprint of a time when everything was still being decided, when nothing was settled, and yet somehow, beauty still formed. Pluto was never meant to be still. From the distance of Earth, it may seem frozen in place, a lonely speck drifting in an orbit too wide and slow to stir interest. But up close, where the light is thin and the temperatures fall far below the reach of comfort, something remarkable is happening. The surface whispers of change. The scars and stretches of its terrain suggest motion, renewal, restlessness. Pluto is not just a fossil. It's a cold world that might still be alive. When New Horizons flew past in 2015, it saw more than just ice and craters. It saw evidence of a planet still sculpting itself. One of the first surprises was the smoothness of certain plains. Wide, flat expanses like Sputnik Planitia, so untouched by impacts that they seemed impossibly young. On a world with no atmosphere thick enough to erode, no rainfall to wash away age, and no plate tectonics as we know them, smooth surfaces tell a specific story. Something is refreshing that landscape. Something beneath is stirring. Cryovolcanism is one possibility. Unlike Earth's volcanoes that spew molten rock, cryovolcanoes eject slushy mixtures of water, ammonia, and other exotic ices. On Pluto, where the surface is locked in nitrogen frost and the temperatures hover around -390 degrees Fahrenheit, water ice behaves like granite, while softer ices act almost like lava. These cryovolcanic flows don't glow or roar, but they spread slowly, reshaping the terrain in silence. Two large features, Wright Mons and Picard Mons, appear to be cryovolcanoes. They rise gently from the surface, broad and low, with central depressions and fractured flanks that hint at past eruptions. But what kind of heat would drive such activity in a place so far from the sun? That question opens a deeper mystery. Internal heat on Pluto could come from the decay of radioactive elements, the same kind of slow energy that warms the hearts of larger, rocky planets. If Pluto retained enough of these elements from its formation, it might still generate enough internal warmth to power convection, or even a subsurface ocean. This heat wouldn't radiate in waves or steam. It would creep, pushing upward over eons, softening the ice, reshaping the crust, causing the surface to sag, stretch, or crack. And cracks are everywhere. Some of the most telling signs of activity on Pluto are the long fractures that cut across its face. Some stretch for hundreds of miles. These aren't simple breaks. They're signs of tectonic stress, of expansion and contraction in the crust. That kind of motion doesn't happen on a dead world. It suggests Pluto's interior is adjusting, swelling or shrinking, possibly as its internal ocean freezes or changes state. The crust stretches as pressure builds, and then something gives. A line opens, slow as breath, leaving behind a jagged signature of motion beneath. These tectonic features are different from Earth's. There are no plates here shifting past each other in great collisions. Pluto's tectonics are quieter, subtler, less violent, but they are still profound. They imply an active interior, or at least one that hasn't completely gone still. Some models suggest that Pluto's core, made of rock and surrounded by layers of water ice, may still be warm enough to permit movement. If there is an ocean, and some believe there is, it could be insulated by layers of exotic ice that behave like blankets, trapping the heat and allowing liquid water to persist under the shell. It's a haunting idea that under all that frost, beneath layers of nitrogen and methane and carbon monoxide, there might be a secret sea. Not deep or wide, but ancient and enduring. A hidden ocean on a distant world, sealed in darkness, untouched by light, yet still fluid, still waiting. If such a thing exists, it changes our idea of what is necessary for planetary life. It expands the boundaries of habitability. It makes Pluto, in its quiet coldness, a kind of beacon, not of life perhaps, but of the potential for it. Even the ice floes on Pluto are active participants in this story. Sputnik Planitia, that great heart-shaped plain, is not just frozen in place. It moves. The nitrogen ice there appears to be convecting, cycling in slow, undulating motion as warmer patches rise and cooler ones sink. It's a glacial motion on timescales of hundreds of thousands of years, but it is movement nonetheless. You can see the cellular patterns on the surface, shaped by this quiet churning. They are like fingerprints of breath in the deep freeze. All of this leads to a quiet but persistent question. Is Pluto still evolving? We don't have all the answers yet. The Flyby gave us a snapshot, a moment frozen in time. We need more data, more missions, more time. But what we've seen already suggests that Pluto is not static. It changes, slowly, silently, but undeniably. The forces shaping it may not be dramatic, but they are real. And they speak of a world that refuses to settle into stillness. There is something poetic about that, about a place so far from the sun, so long exiled from the title of planet, continuing to defy expectations. Pluto, once dismissed as a relic, is turning out to be one of the most dynamic, surprising objects in the solar system. Its activity isn't loud, it doesn't flare or quake, but it endures. It sculpts, it remembers, and in doing so, it challenges the very idea of what it means to be alive. In the end, Pluto's vitality is not measured in explosions or storms. It's in the slow grinding of ice, the whisper of heat, the ghost of water beneath the surface. A cold world, yes, but not a dead one. Not yet. For most people, Pluto didn't begin as a discovery. It began as a story. Maybe it was a line in a school book, a little diagram in the corner of a solar system chart, a tiny dot far from the sun with a crooked orbit that set it apart. Or maybe it was a moment in a classroom when a teacher listed the planets and ended with that strange, mysterious name, Pluto. Small, cold, distant, but somehow essential to the tale. It was a planet that didn't quite fit, and that made it easier to remember, easier to love. Before we understood what Pluto was, it had already become something we carried in our imaginations. It was the underdog planet, the little one at the edge, the one that didn't shine as brightly but was still part of the family. When textbooks drew the solar system, they often stretched the orbits to make space for Pluto, as if it needed a little extra room just to be noticed. In a universe where scale is often compressed and sacrificed for simplicity, Pluto was always invited. It sat at the table, quietly, with a name too large for its frame. That name, of course, helped. Pluto. Not 134340, not an alphanumeric designation from a distant observatory. A real name, plucked from mythology, softened by time. The Roman god of the underworld, guardian of hidden realms, chosen not by scientists or committees, but by an one-year-old girl, with a fascination for the classics and a sense of imagination that reached across continents. Venetia Burney suggested the name, and astronomers said yes, and just like that, the cold world had an identity. More than just numbers, more than data. It didn't take long for Pluto to slip out of science and into stories. In cartoons, it became a name for a dog. Loyal, playful, a sidekick to a mouse that ruled the world of animation. There was something ironic, almost surreal, about a celestial body being mirrored in a creature with ears too big for his head and a bark that never aged. But it worked. Pluto the planet became Pluto the character, and in doing so, it found a home in childhoods everywhere. You didn't have to know orbital mechanics to love it. You just had to be awake on a Saturday morning. In films and books, Pluto played a different role. It was the mysterious endpoint, the gateway to the outer solar system, the place where lost ships go and alien signals originate. It was the edge of known space, quiet, dark, and waiting. Science fiction writers loved its ambiguity. It was distant enough to hide secrets, close enough to be reachable. The perfect setting for mystery. You could write anything into Pluto because so little was known about it. In a way, that made it limitless. And then came 2006. It wasn't the first time the idea had been debated, but it was the year the International Astronomical Union voted to redefine what a planet truly was. The decision was meant to clarify, to bring order, but it had the opposite effect. The new criteria, orbital dominance, hydrostatic equilibrium, and a clear path through its orbit, disqualified Pluto. Not because it had changed, but because the definition had. Suddenly, textbooks were out of date. Models of the solar system were redrawn. The list of planets shrank from 9 to 8, and Pluto was left behind, recategorized as a dwarf planet. The backlash was immediate. Scientists debated the merits of the new definition, arguing over the value of orbital cleansing versus cultural significance. But the public didn't argue. The public mourned. For many, it felt like losing an old friend. Pluto had always been small, but now it was being told it wasn't even special. Not a planet, not part of the family, just a dwarf, sharing its new title with bodies most had never heard of. Eris, Haumea, Make, names that lacked history, names without stories. The media ran with it. Headlines blurred between outrage and disbelief. Talk shows joked about Pluto's demotion. Late-night hosts ran mock obituaries. Social media, still young but growing fast, lit up with hashtags, number Pluto is a planet, number justice for Pluto, number reinstate Pluto. It wasn't just science, it was sentiment. Pluto had become a symbol of something more, a stand-in for all the things we hold on to even when the facts change, an emblem of memory, of loyalty, of resisting the cold logic of reclassification. And beneath the humor and hashtags was something real, a quiet reminder that science doesn't exist in a vacuum. It exists in people, in the way they learn, the way they imagine, the way they form attachments. Pluto had been a planet not just because of its orbit or mass, but because generations had grown up calling it one, because it had meant something, because it had helped build the map of the sky we carried in our minds. Even now, Pluto holds that place. Textbooks may change, and definitions may evolve, but Pluto still shows up in classrooms. Teachers still tell the story, often with a smile. Students still ask why. And artists, filmmakers, writers, they still reach for Pluto when they want to say something about distance, or loneliness, or the wonder of the unknown. It's shorthand now, for mystery, for nostalgia, for the edge of things. Pluto lives in science, yes, but it also lives in culture, in hearts, in stories passed quietly between generations. Not just a world, a symbol, a reminder that even the smallest things, the furthest things, can matter deeply, can inspire, can belong. Out past Pluto, the light begins to thin into something like memory. The sun is still there, still burning, but from this distance it feels more like a rumor. Its warmth faded into an ember, its brilliance softened to a pale dot in the endless dark. You can hold your thumb up and block it out completely, and what lies beyond is not absence, but possibility. Beyond Pluto is where the solar system forgets its boundaries, where the edges blur into places we've never walked, never touched, never fully imagined. When New Horizons passed Pluto, it did not stop. It couldn't. It was moving too fast, its trajectory set in motion by years of planning and gravity assists, and the quiet urgency of curiosity. But even as it raced by, it turned its gaze forward. It looked past the lonely orbit of Pluto, into a region the maps used to leave blank, not because there was nothing there, but because we hadn't seen it yet. The Kuiper belt, a scatter of icy bodies, fragments of early solar system construction that never coalesced into planets, a debris field from creation, silent, ancient, and waiting. We used to think of the solar system as ending with Pluto, 9 planets, and then the void. But the Kuiper belt changed that. It wasn't just a ring, it was a revelation. A whole new region of space, teeming with frozen remnants. Some were round and smooth, others jagged and chaotic. Some spun quickly, others drifted slowly, tumbling through the dark. They had names we'd never heard before. Eris, Haumea, Make, Sedna, and others that had no names at all, just catalog numbers and trajectories traced faintly across the stars. Among them was Arakoth. When New Horizons reached Arakoth in 2019, It was like opening a time capsule sealed for billions of years. The object, small and peanut-shaped, floated in the cold like something exhaled by the early solar system and forgotten. It was pristine, untouched by collisions, unaltered by heat. Two lobes gently fused together, not shattered or scarred. It looked fragile, like something made of dust and dreams. And it told a story, not just about what the solar system is, but what it was, how bodies form, how gravity pulls without violence, how some things come together gently and stay that way for eons. The extended mission beyond Pluto was never guaranteed, but it became essential. Once you pass through the gate, how can you not go on? New Horizons had already shown us a living world at the edge of our maps. Now it was showing us the cemetery of creation. The Kuiper belt was no longer a mystery. It was a neighborhood. Strange, yes, but not empty. And with every observation, it whispered a new truth. Pluto was not an exception. It was a member, one of many, but also, somehow, still one of a kind. Now, there are murmurs of something more, of going back, not just a flyby, but a stay, a Pluto orbiter, someday, a spacecraft that wouldn't just glance and flee, but linger, circle, watch, wait. We dream of it now the way people once dreamed of landing on the moon, a dream built not just on technology, but on longing, because Pluto gave us more than we expected. It gave us mountains made of water and plains made of nitrogen, skies that haze blue and snow that never falls the same way twice. It gave us questions that didn't exist before we arrived. And the question now is, what else waits? Beyond Pluto, the solar system doesn't end. It just becomes quieter. The space grows larger. The orbits stretch longer. Light becomes a traveler with aching feet. Communication with Earth takes hours. Heat becomes a memory, locked inside cores that may never feel it again. And yet, these places are part of our story, part of what made us, part of the dust and chaos that circled the sun before Earth was Earth, before oceans, before breath, before names. We stand on the edge of exploration, and that edge is moving. With every mission, every map, every glimpse of a light curve or thermal echo, the frontier shifts outward. What once was myth becomes model. What once was speculation becomes science. And what once was just a pale dot at the edge, Pluto, becomes a gateway. The frontier is not a line. It is a feeling. It is the soft pull of the unknown. And it is not behind us. It is ahead, always ahead. The word planet used to feel so simple. A tidy label we gave to the biggest, boldest objects circling our sun. They had names from myth and histories written in textbooks, and we memorized them like a litany. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. It had a rhythm, a shape. It felt settled, until it wasn't. Until the very definition of planet became something soft around the edges, something debated, something political, something personal. In 2006, a vote held by the International Astronomical Union in a quiet room in Prague changed everything. A new definition was drawn like a line in dust. To be a planet, a world must orbit the sun, be massive enough to become round under its own gravity, and must have cleared its orbit of other debris. Pluto failed that last part. Not because it wasn't strong or significant, but because it shared space. It traveled through a cluttered lane in the Kuiper belt, surrounded by other icy bodies like Eris, Haumea, and Makemake. Suddenly, it was not a planet. It was a dwarf planet. The decision felt like surgery, clinical, precise, and irreversible. But not everyone accepted the cut. In the years since, scientists, educators, and the public have argued, gently and not so gently, over what that word should mean. Should a definition crafted in a meeting hall carry more weight than wonder? Should orbital dominance outweigh geological complexity? And what do we lose when we take away a name? Alternative definitions began to bloom in the cracks of that 2006 vote. Some proposed a geophysical model, one that defines a planet not by its orbit, but by its shape and nature. If an object is round, shaped by its own gravity, and not a star, then it should count. By that standard, Pluto qualifies. So does Earth's moon. So do dozens of other distant, spherical bodies scattered across our solar system. The model expands our family. It includes instead of excludes. It tells us that size isn't everything, and that solitude isn't a requirement for identity. For some, this broader definition feels like a restoration. For others, like dilution. But beneath the disagreement lies a deeper truth. We're still trying to understand what a planet is because we're still trying to understand what worlds are. The more we discover, the harder it becomes to draw clean lines. Space doesn't organize itself into our categories. It resists simplicity. It forces us to confront the messiness of creation. Pluto complicates things, and that's part of why we love it. It's not just a ball of ice at the edge of the system. It's layered and active, with weather and mountains and a possible ocean buried in the dark. It has moons that dance instead of orbit. It has a heart-shaped plane that pulses with geological energy. It's small, yes, but it's alive in ways we didn't expect. It behaves less like a frozen leftover and more like a world with stories to tell. And in that complexity, it earns something beyond category. Even after the IAU vote, people didn't stop calling Pluto a planet. Teachers hesitated when updating lesson plans. Students asked why something so beloved could be demoted. Astronomers debated on podcasts and in journals. Hashtags bloomed. Number Pluto is a planet. T-shirts, pins, protest signs. There was grief and there was humor. And beneath both was a kind of defiance. Pluto mattered, and it wasn't going quietly, because sometimes definitions bend to emotion. Sometimes a word means more than its parts. We call Pluto a planet, not because of a checklist, but because it feels like one. It orbits the sun like the others. It spins. It has seasons. It surprises us. It invites questions. It evokes wonder. What more could we ask of a planet? The debate hasn't died. It probably never will. And maybe that's a good thing. Maybe the argument itself is a sign of curiosity still alive. Science is not a fixed thing. It's a living, breathing conversation. And Pluto, in being hard to define, forces that conversation to evolve. It reminds us that categories are tools, not truths. They help us understand, but they don't always capture what something is. Pluto is still out there, orbiting slowly through the dim blue haze of the outer solar system. It hasn't changed, not really. Only our labels have. And maybe, someday, those labels will shift again. Maybe they'll expand, or soften, or dissolve completely. But even if they don't, Pluto will still be what it is. A world with mountains and plains and air that turns to frost. A world with color and cold and motion. A world that was once the 9th planet, and still, in many hearts, remains just that. A planet by any other name, Pluto is still turning, still carving its slow arc through the far dark of our solar system, where the sun is little more than a sharp star in a pale sky. It's still there, unchanged by our arguments and definitions, still holding on to its secrets with a kind of frozen grace. And maybe that's part of the magic, that a world can remain so quiet, so far, so unreachable, and yet stir so much feeling here, on a planet it has never seen and will never touch. Its mysteries are many. Some we've glimpsed through the lens of a flyby, others we've only imagined in models and theories. A heart-shaped basin made of nitrogen ice, smooth and craterless, suggesting a surface, young and restless. Mountains made of frozen water, harder than granite in the deep cold. A sky that turns blue at sunset, laced with haze and dust, hinting at a chemistry that's still unfolding. There may be an ocean, liquid and buried, sloshing slowly beneath the crust. There may be heat, somehow, somewhere, pulsing from the core of a world we once thought too small and too distant to be alive. And then there are the moons. Charon, Pluto's twin in a perfect tidal lock, forever showing the same face in an endless, slow embrace. Nyx and Hydra, Styx and Kerberos, each moving in strange, looping dances that defy the neat orbits we've grown used to. Their patterns are chaotic, but not random. Their rhythms feel improvised, but not without harmony. It's like music played in a key we don't yet understand. Pluto didn't just reveal itself. It reframed everything around it. It made us look again at what a planet is, at what it means to explore. It reminded us that the solar system is not a tidy place of 9 perfect spheres, but a dynamic, evolving family of objects. Some massive, some minuscule, some bursting with heat, others wrapped in ice and silence. Pluto showed us that the edge is not the end, that even in the outskirts, beauty persists, complexity thrives. This little world, once the 9th planet, once forgotten and then rediscovered, holds a mirror up to the way science grows, not through certainty, but through curiosity, not in answers, but in better questions. What keeps Pluto geologically active in such deep cold? Could its ocean be real? And if so, what lives in its shadows? How did it form? Why is it so different from the others? How many other Plutos are out there, waiting, unseen? These aren't just puzzles to solve. They're invitations to wonder, to reach, to dream of distant surfaces and silent skies. They remind us that space is not empty. It's alive with potential, with stories we haven't heard yet, with places that are not just cold and dark, but intricate, expressive, even emotional in their own way. Wonder is not a luxury. It's not something frivolous or childish. It's a survival trait, a tool that helps us grow, that pulls us into the future. It's what builds telescopes and launches probes. It's what writes books and builds dreams and paints the sky with meaning. And Pluto, lonely, lovely Pluto, is a spark for that wonder. We live on a warm world close to the sun. We look up, mostly at night. But even then, with our cities glowing and our atmosphere shimmering, we can barely grasp what's out there. The distance is staggering, the scale is humbling, and yet we reach anyway. We send spacecraft across decades of time. We wait for data to cross billions of miles. We name the unnamed. We argue and revise and draw diagrams in the dust. And sometimes, a place like Pluto answers back, not with words, but with color, with motion, with quiet complexity. It tells us, simply by existing, that we haven't seen it all, that the edges are just beginnings, that some places refuse to fit our expectations and become something better instead. So if you find yourself wondering about planets, about space, about how something so far away can feel so close, know that you're not alone. Know that you're doing what humans have always done, staring into the dark with hope. Know that wonder is a kind of light, and that Pluto, with all its ice and silence, reflects it beautifully. It is a world worth wondering about, and that wonder never really ends.